Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will learn how to simulate multi-phase surface pump using Prosper software. All right, so we are now inside the Prosper software. We go to the first section, double click. Okay, so you can follow me. Fluid, oil and water, method, black oil, separator, single stage separator, no emulsion, disable warning for the PVT warning. And for the water viscosity, we will use default correlation, viscosity model, Newtonian fluid. And for the well, flow type, tubing flow, well type producer. And this is the important section, the artificial lift. Open the drop-down menu and find the multi-phase pump. Okay, and in the type, we can have one subsea H series, one subsea HX series, and the soldier. In this video, we will try this series, H series, and you can also type in the user information, company, field, location, well, platform, and the analyst. And for the calculation type, to predict, we will use pressure and temperature for the offshore case and model rough approximation. And for the range, full system. And for the brine properties correlation, we will use default correlation. And for the well completion, case hole type, and for the send control, none. And for the reservoir, inflow type, single branch, and no gas coning. You can also type in your comments in this section. Okay, so we can click done. And from here, we will go to the PVT section, the second section. All right, in this case, we don't have laboratory data, so we will not do PVT matching. If you have the data, you can do the matching. Okay, so for the solution GOR 800, standard cubic feet per stock tank barrel with the oil gravity of 37, gas gravity of 0.76, water salinity 23,000 ppm, no H2S, no CO2, and no nitrogen. For the bubble point pressure, solution GOR and oil formation volume factor, we will use Glasgow correlation. You can also use other correlation, all right, in this drop-down menu. And for the oil viscosity correlation, we will use Bill et al. All right. And you can also check the composition data here if you're interested. And for the warning, no important data here. Okay, and then for the viscosity modeling, viscosity model Newtonian fluid, emulsion, no emulsion. Okay, so from here, you can leave it as it is, leave the other, done. All right, so from PVT section, we can go to the IPR section, double click, and you can see we have several models to model our IPR. We have PI entry, productivity index entry, Vogel, composite, Darcy, Fedkovich, right? In this case, we will use PI entry to make it simpler for us. And the reservoir pressure, 4,800. With the reservoir temperature of 210 and water cut of 80%. Total GOR automatically populated with 800 standard cubic feet per stock tank barrel taken from the PVT section. No compaction and no relative permeability data. And in this model, PI entry model, it is very simple. You just need to provide productivity index data. And in this case, our PI is 8 stock tank barrel per day per PSI. Okay, so far so good. So we can click calculate and fast enough, you can get the AOF, the absolute open flow or maximum flow rate of 30,000 stock tank barrel per day. We can also plot the result. For the x-axis, I want to show the flow rate. Whereas for the y-axis, the vertical axis, I want to show the pressure. Click done. All right, so this is my IPR. All right, starting from the reservoir pressure of 4,800. And at zero pressure, I will have this one as my AOF, or maximum flow rate, of 30,000 ppm. Oh no, 30,000 stock time barrel per day. All right, with PI of 8 STB per day per PSI. All right, so far so good. So we can click finish, click done, click done. Okay, so you notice in this multi-phase pump case, we have another or new section here. You can double click to open it. All right, we have one subsea H series pump input data. We will input the data later on, and I want us to fill in the data here in this section first. So I will check this one, surface equipment, because we will involve the surface pump, surface multi-phase pump, right? Downhole equipment, of course, and the geothermal gradient and average heat capacities. Okay, and we click edit. All right, so the first section is deviation survey. So you can follow me. We have measured depth and true vertical depth, MD and TVD, 0 and 0. And then for the second row, 600. 1005, TVD of 1000, 4075 at 4000 TVD, and then 7700 at 7500 TVD, and lastly 9275 of MD at 9000 TVD. Okay, and you can have this cumulative displacement and the angle calculated automatically. You can click plot. All right, so we have a deviated well in this case. Finish, done. All right, so for the second section, we need to input surface equipment data.